In this video, we'll discuss the summary of the hyperbolic function. And we are going to discuss the function of a over x plus q. And our main focus would be on the value of a and the value of q. So let's start by discussing the values of a. In our first example, we'll discuss the values of a where a is bigger than 0. What it means in the hyperbolic function when a is positive is that the function would be in the first quadrant and in the third quadrant. So if you want to learn how to count the quadrants, you start from the x-axis and you move in an anti-clockwise direction around the Cartesian plane. And we can see that the y-axis and x-axis divides the Cartesian plane into 4 parts. So the first part is quadrant 1, then I have quadrant 2, below that quadrant 3, and then next to that quadrant 4. So when a is bigger than 0, or another way to say it is when a is positive, the function would be in quadrant 1 and quadrant 3. For our second example, we'll focus on when a is smaller than 0, or when a is negative. Now the function would be in quadrant 2 and quadrant 4. So if I were to draw the function, I'll find it in quadrant 2 and 4 when a is a negative value. Let us discuss the axis of symmetry for the hyperbolic function. Now this function has 2 possible axes of symmetry. So what an axis of symmetry is when I take the curve in quadrant 1 and I fold it over a line, we want to find the equation of that line where the curve in quadrant 1 would fit exactly on the curve in quadrant 3. That is called the axis of symmetry. And on the right hand side, we can find the equation of the line where the curve in quadrant 2 would fold exactly on the curve in quadrant 4. This is also known as the axis of symmetry. In our second example, the axis of symmetry is where y is equal to x. Meaning, if I plot a point on the graph, the x and y value would always be exactly the same. So the equation of this axis of symmetry is where y is equal to x. And on the left hand side, I have y is equal to negative x. So when I plot these points on the graph, if I have a y value of 3, the x value would be a negative 3. And if I have a y value of negative 2, then the x value would be 2. But I can also add another axis of symmetry in our first diagram. And this line is where y is equal to x, exactly as our second diagram. Now what happens here is, if I fold the graph over this y is equals to x line, then the top part of the graph in quadrant 1 would fold exactly on the bottom part in quadrant 1. And the same thing happens in quadrant 3. So if I fold it over the axis of symmetry, the top part of the graph would fold exactly on the bottom part of the graph. And the same is true for the second diagram. You can also have an axis of symmetry of y equals to negative x. Now let's move on to discuss the value of q. Q represents a vertical shift. So when q is positive, it will be an upward shift, and when q is negative, it will be a downward shift. And q would also represent an asymptote. An asymptote is a line where the graph can never exist. So this function will never touch this asymptote. So here I've drawn a graph of the hyperbola where a is a positive value. And you can see that it has 2 asymptotes. The first is the y-axis. This function would go extremely close to the y-axis but never touch it. So on the right hand side, the graph will go extremely positive but never touch the y-axis. And on the left hand side, the graph would go extremely negative and get really close to the y-axis, but they would never intersect. So this asymptote is where x is equal to 0. And our second asymptote is the x-axis, because if I go to the right, the graph will never touch or intersect with the x-axis. And if I go to the left, the same is true. And the equation of the x-axis is where y is equal to 0. Let's say I shift the graph up, for example, by 1 unit. Now what I've done is I've moved the graph up by 1 unit. But the asymptote is still in place. But it no longer is the x-axis. It is now at y equal to 1, because we have shifted the graph up by 1 unit. And we can also shift the graph downwards by how many units we would like. So in this example, horizontal asymptote is now at y is equals to -2. So at y is equals to -2, the graph would never touch or intersect with this equation. And this represents a Q value of -2. Follow the grade 10 functions playlist, where we have videos on finding the domain and range of graphs, how to sketch graphs, finding the equations of graphs, and also test and exam type questions.